Okay. Whew. So I've got to talk about end-to-end testing and why the game has changed. So I actually have a little story to share as well that's kind of personal, but it means a lot to be here today. So this is, my name is Will, and this is my wife, Diane. 5 years ago, we went to our first JSConf in Florida in the US. This is us on Amelia Island. It was a really great time, and I really appreciated that JSConf welcomed not just us in the community, but our significant others and our families. I think it's really important to value that, and I really appreciate that that tradition is continued here today. I had a question at the time that I was trying to figure out the answer to. How do you test your front end? I think we've got some really good answers about how to test our unit tests, how to test our functions, our classes, and our UI components in isolation. I think it becomes more difficult when we try to integrate all these things and put it all together. A lot can go wrong on whether it's our UI or our web APIs or our backend or our database or even our deployments. When we put all those things together, anything could break down, and we could have all the unit tests in the world, and they won't help us in those cases. So the type of tests that try to exercise this are called end-to-end tests, testing things from one end all the way to the other and back. I had a lot of really great conversations at the conference. Sorry, just need to move my mouse off. I had a lot of great conversations, but one stuck out. I met this person, Nicholas Bull, and he talked to me for hours. And little did I know, but his wife was also at the conference, Katrina, and she was quickly becoming friends with my wife while we were hanging out talking about testing. And he talked about all the tests that his team had written. They had thousands and thousands of unit tests, lots and lots of integration tests, and maybe 1,000 or so end-to-end tests, which is quite a lot. They were testing an enterprise app, which is just an app that does way too many things. And I was so impressed with all the things he had to say about their stack and their tools and all the effort they put in. I applied to work at his company, and a few months later, my wife and I moved out to Colorado, joined his team. He and his wife helped us unload our moving truck twice, and helped us settle in, invited us over for the holidays, and became close friends. It was really awesome to have met them at the conference, and now we hang out so much together today. So when I joined this team, I found they were using a tool I was actually quite familiar with, Selenium. So Selenium is a tool written in Java that lets us test our apps from the point of view of the browser. And it's a little bit old, but it's done a lot of wonderful things, and it's let us do something we might not otherwise be able to do. And the way it works is it's got this Java service that just listens for commands. And you write test code in any language, actually, and more often than not JavaScript. And that language would usually use a library to speak the language of Selenium, the Webdriver API. It would send those commands to the service, and the service would queue all these commands and would try to send them to any given browser, real browsers. And so there was just a number of different abstractions and integration and interfaces where things could go wrong. It could be that your test code had an issue, or you're using the API different, and all the different APIs to work with Selenium in every language, and even within JavaScript, there's several choices. They're all a little bit different. Those could have issues, or you could be using it incorrectly. The Selenium service queuing up those commands and sending them to the browser drivers. For each browser, the browser drivers could have bugs. There are a lot of ways where this could go off the rails just with this architecture. So the greatest complexity of all is our app. I find that as we write modern JavaScript apps, we're doing a lot of things now in the browser. We're making all these different API calls just when the page loads. Those come back in different timings, different orders sometimes. That can cause just different behaviors in our front end. Whenever the user interacts with, with our UI, That makes more calls, more things happen. And all these things happen asynchronously. So we are rendering, it could finish at any time, and we don't really necessarily know when it is, at least from our test code's point of view. Us as users, as humans, it's very intuitive to us, but when we run our test code, it does exactly what we tell it to do. And if it clicks a button and then it starts to re-render, and we try to do the next thing, we need to be very careful about knowing that it finished rendering, or we might get something very unexpected. So the greatest problem of all is when we take this Selenium architecture and combine it with the complexity of our apps. It's really a recipe for just frustration. And what we'd find is we'd write a commit, and we'd run tests locally, and everything would look good. We'd push it to the build, and it would fail. Some tests would fail, and usually an end-to-end test. And we'd run that build again, because it was a test that we shouldn't have broken, and it would pass. And we'd see this over and over again, where different commits would just randomly fail just different tests. And we call this flakiness. And the problem might be something with the Selenium architecture. Often it was a combination of that and just the complexity of our app working in with different performance characteristics. Particularly when we're on build environments, they're virtualized, things can slow down, or the database, anything could make it just work a little bit slower in one part of the stack. At any given time, and just something will fail somewhere. We ran into this so much, we had a build job that would just continuously run and check the latest commit on master and just run all the tests. And it would just flush out dozens and dozens of tests that just failed a lot. Even with that, we just kept tripping over this issue over and over again, tests that would just fail once in a while. Why do we keep doing this? Well, these tests we found to be extremely valuable. As I said before, you could have all the unit tests in the world, but if everything integrates and something breaks down, you're going to have a really bad time. And worst of all, your user's going to have a bad time. I mean, this, at the end of the day, everything we do is about building a user experience, building value so somebody can do their job or do that part of their life or make that one thing easier that gives them joy and makes them happier or productive. So we invested as much as we could into making this better. I mentioned the flaky finder, but we even tried to make our tests better in a lot of ways. One example, we wrote some test helpers that would try a command, and if something didn't work right, it would retry it a number of times or for a certain timeout. And this is called an implicit wait, just building it into the API so you don't have to do that manually in your code. So we also found that it helped to mock some service once in a while, mock some services to test certain edge cases or certain scenarios, large data, things like that. Doing that, we wrote some of our own service mocking libraries to make that process easier. We invested as much as we could into making the developer experience of using our tests and running our tests better, so we'd keep doing it, despite how painful it was. So after a while, I joined a new team and got Selenium up and running there, and that went all right, and ran some of the same issues. And then just this past fall, in October, I was consulting on a project, and we had run into a serious quality problem. We didn't have a dedicated QA team, and as much as we smoke tested our app on every single commit, there were always cases we missed. And at any given time, something would stop working, and you didn't know when it happened. So we decided to write some more tests. I pulled the story to write the end-to-end tests. And I pulled down Selenium, and the first thing I had to do on my year-old MacBook was install Java, install the JDK, because I didn't have that, and you need that for Selenium. I thought, wow, I still wish this was written in JavaScript. So the next tool I tried was Cypress. And Cypress was something that I had actually held off on using for a while. It'd been closed source up until, I think, May last year, and it had been in private beta until October. And they had built a company around some of the premium CI features, but now that it's open source, everything that you need is just right up there on GitHub. If the team stopped doing what they're doing, the community could pick it up and run with it. So I'd really waited to use this until it was open and freely available. It was something I wanted to use that was MIT licensed and ready to go. So I actually used it for just maybe 2 hours, and I was blown away. I was so shocked by how different and better my developer experience was that I wrote a proposal to a conference after just working for a couple hours, and here I am. So I have a few demos that I'm just going to run through to show you how to install it, set it up, what some of the tests look like. I don't want to get too hung up on any of the syntax or any of the commands. I just want to give you an idea of what it's like. So the first thing you do is you just npm install it. And this actually will do a download from their website and pull down the right Cypress app. There's an Electron app involved, so it's going to pull down based on your operating system and your CPU architecture. Next, you open it. And the first time you open it, it kind of initializes some things. It makes sure it's verified and it's like the right thing and all. And then when it runs, there's this little pop-up saying, hey, to help get you started, we put some files in the file system. And you might want to take a look at that. The files are basically examples. This is just nice. There's an example like fixture, there's example plugin, custom commands, and an example spec. And the example spec is just this kitchen sink of all the different commands you might want, and it just gives you that quick reference right in the repo. I mean, you can go to their docs, but it's just all right there, and just kind of gives you a little head start with what you might want to try to do. The nice thing is, from there, it starts to get very familiar. If you've ever done BDD style tests, whether in Jasmine or with Mocha and Chai, the syntax is going to look very, very familiar. Let me make this just a little bit bigger. That big? Oh, yes, that worked. Good. All right, cool. All right, so this is just part of a spec file. And the first thing is, like, there's this top-level describe. We're describing our app or some view in our app. And we can have before eaches, if we're used to that, and do things before every test. And most commonly, we'll load the page, load a route on our app. And then from there, we can have nested describes or contexts in Mocha. And we can have our it shoulds. It should do a thing. It should focus on the to-do input field. And then from there, we can start using the Cypress API. In this case, we're doing two things. We're doing site.focus, which says, hey, Cypress, look up what's currently focused in the window. And then it tries to do an insertion. It does a should, and it says it should have the class new to do. There's something interesting about the should, and this whole, you'll see some chaining here, and there's a reason why they use that style. See, the should has this context of, I'm trying to do a should on something that was focused, or something that I tried to get in the DOM. The should will keep trying until it's true, until there's a timeout. This is really nice because when we first load our page, like we talked about asynchronous rendering, the first thing that's focused might just be the window or the document. That thing hasn't rendered that has that class. So it's going to keep retrying until it gets that, until it passes. And this permeates all of their APIs, and having that context and doing things just a little bit more intelligently by nature. I'll show you one other example. This is an example that is quite common where you try to just get something based on a selector. It's using jQuery under the hood, so anything that's really a valid selector works, and you can even do things similar to in jQuery with DOM traversals to like get siblings or next or parent, etc. And then we just type in a little thing we want to do. And another thing I'll point out is instead of having to memorize those key codes, like what key code do I need to put in to automate an enter key or an escape key, they just use like enter with curly braces. Just nice and convenient that way. From here, I want to show you what running the test looks like and what debugging the test looks like. All that other stuff is relatively similar to Selenium in terms of like we're just writing tests and using some API. This is where I think it starts to take off. So the first thing is you can run it headlessly. By default, it runs headlessly, like on the CI or for just running tests locally before on a pre-commit hook. There's some nice results there telling you everything that passed, and there's also recording by default, so you can actually replay the recording of your app and all the tests if you want. And here's where it starts to get a bit different. There's an Electron app. And the first thing that happens when you load the Electron app, there's this yellow warning that says, hey, can you make sure you're running your web server? There's a configuration you can set, your base URL, and if you configure that, it'll actually check that when this Electron app runs to make sure that you're running your web server. I can't tell you how many times I've forgotten to run my local dev server when I'm running my tests. And it just tells you right away. And then from there, you can also choose which browser, and just whichever version of Chrome you want right now, and or Firefox and Edge and all that eventually. I'll get to that. And then you can run your spec. So from here, we get into the test runner. The test runner is pretty neat. This is not this part. Run it? OK, good. So this part's pretty neat. This is running in a browser, like a sandbox browser environment. And the test runner is this whole, like, there's our tests on the left. There's this header on the top that has like this information about what tests have passed, which tests have failed, how long it's been running. We can stop and replay it. There's a URL preview. There's a little target icon. That's actually a DOM Selector Playground. We can click on that and play around with selectors to find things in our app. And there's also viewport information at the top. And on our right is our app. So this might seem like a little thing, but this, just having it right in the same window is very convenient. And there's a very good reason why they put this all in the same window. So that thing on the left, where all our commands and all our tests are kind of logged, that's called the command log. This thing is cool. When we click on anything in there, expand one of our tests, we see all the commands that our tests tried to execute. If we click on any of those commands, it'll jump to that part of the test. It'll actually go to the DOM. It takes DOM snapshots throughout the test, and it replays those DOM snapshots. So we can actually jump around our tests sequentially or out of order and replay the state of our DOM and see what's going on in our app without having to, without much effort. And you'll see there's this thing at the bottom of our app that says before and after. Certain commands have this context of before and after. I think typing is one of them. So if you go to type in something like a new to-do, you hit before, you can see the to-do before something got typed, see what's going on, debug it maybe. And you can click to the after and see after you've done the type command. This ability to replay the DOM snapshots and walk through our tests just by clicking on the command log is a night and day difference from anything I ever experienced with Selenium. The workflow I was used to was setting up a debugger and trying to drop a breakpoint in my test or my app code and trying to hopefully stop at the right point, running into all kinds of things like default timeouts and the app reloading and test reloading and just all kinds of wonkiness that was just always frustrating. And just being able to walk through my tests, I can see exactly what's happening. And just a little aside, interesting thing, if you write really good tests about your app like this, you can actually sort of document how your app works, and a new user or a new person on the team could look at it and get a pretty good understanding of all the things it does and how it behaves and what it looks like, all of that. So let's talk about debugging, like really debugging. So the first thing is when we click on those things in the test runner, we get any of the things we click, they have some context of there's a DOM element involved or there's a network request. If we click on them, they just get logged to the console. Normally, I'd have to set up a breakpoint and throw in my own console logs to get this information. And it's just right there, like just at a click. We can get that and start playing with it. DOM debugging, you can inspect the state of the DOM in any of these snapshots, and you have that, and you can rely on that. I will say, it's not necessarily replaying all of your different Redux states, for example, your true app state. It's just going based on the DOM. Though I have found that in reality, even with an app using React and Redux, I was able to actually interact with my UI in some cases, and things would just sort of work. And there are hooks to potentially do things like inject Redux state and snapshot that stuff. I haven't gotten to that yet. I'm not sure anybody has. But there's some crazy things we can do with this replayability. JavaScript debugging. So if that wasn't enough for me, I found it really awesome that I only needed to run this one app, this one browser, this one app, and this one debugger to debug both my tests and my app code. This replay is just showing hitting a breakpoint in my test code here, and there's also hitting a breakpoint in my app code. And being able to jump between those two contexts, normally I was used to having like a debugger, hopefully in Node because my tests were maybe written in JavaScript, and then another one in the dev tools for my app. And I would be bouncing around between the two, and there's just all this cognitive load that comes with which one am I in, what am I doing where, and bouncing back and forth, and window switching, and just all that. And when you just start to take this this very challenging thing that we do every day, and you put it in a single place, and you just make it that much easier, it starts to make it fun again. So there are some other nice things. So I mentioned we had to write our own implicit waits. Cypress does that out of the box. There's a 4-second timeout, which is plenty. You can make it shorter if you like. You can override that. There's direct access to the DOM. So in Selenium, everything was being serialized to that service I mentioned. And so you're always just getting a serialized version of the DOM. Because everything's running in the same JavaScript runtime, you're actually dealing with the DOM that's in your app from your test code. Like, you just have it. It's just nice. And there's some service mocking libraries built in. They just made it easy to define a route and define things you want to match on, like a method or a parameter, and you can have it return fixture data. It's just rolled up. And that's the thing overall. Like it rolls up all this tooling that we normally be cobbling together ourselves. Sign on for the request stuff, the service mocking, and jQuery for DOM querying and traversal. Mocha and Chai for the BDD syntax in our tests. It takes care of that for us, so we don't have to select them ourselves or maintain those dependencies. And it just becomes this one cohesive package that is well documented on their site. The other thing I noticed about their site, both in their blog and in their docs, they have lots of little tidbits like this. So this is a thing on timeouts and performance, and it talks about this performance trade-off when you start to extend the timeout, which is like a common trap when running these tests. Something didn't work, it wasn't ready yet, so we'll extend the timeout. Well, I mean, there's a big catch to that, especially if you do it universally. And there's things throughout their docs that kind of throw this out at you, like little tidbits that aren't even specific to Cypress. These are just, like, there's a book in here about how to write good end-to-end tests that could apply to Selenium or whatever else tool you want to use. And I just like that. I like that they're a little bit opinionated, and they just share these things right in their docs. So we just have it. It's just nice that they went that far. There are trade-offs. So I've been talking about how awesome it is. I do want to say, some of the things that it lacks that it can't do yet, or the things you need to consider. It's a new tool. It's a new technology. It's a new thing to bring into your team. There's always a cost for that. I take that very carefully. And it has a style, that chaining syntax. I actually personally don't like chaining that much. But as I said before, there's a reason for it. They like to maintain that context of what you're doing, so that way they can intelligently do the thing that you're doing next, like an assertion. And they're very upfront about their trade-offs. They have a whole doc page dedicated to this, and it mentions both permanent trade-offs and temporary trade-offs. A permanent trade-off is it runs in a single browser tab. I have seen apps that try to open other tabs to do certain things. You're not going to be able to test those things in Cypress. There's also a temporary trade-off of browser support. They didn't try to support every browser right out of the gates. They just chose Chrome-based browsers. So they got Chrome, Chromium, Canary, and Electron browser. They're working on Firefox. They're just fixing issues on that right now, squashing some bugs, and they're going to have that as soon as they can. And I'm sure Edge and so forth will be next. But that's something that is very important, though. Having cross-browser support is key in a lot of cases. And I would suggest still having some Selenium tests just for those situations that Cypress cannot do them. I find that 99% of the value of these tests is easily covered by Cypress, making sure that we exercise our user experience, all the different views, all the different interactions that we care about. Testing each workflow once that the user wants to do A, B, C, test those things. Testing any given, all the different UI components at least once. That's also really important. More than anything, I would say it's ambitious. They've basically reinvented the wheel. And anytime you do that, you're going to have your own set of bugs, your own set of challenges. And I think they not only tried to like reinvent Selenium, but to add this very comprehensive developer experience on top of it. And that is crazy. Like if I ever met Brian Mann, the original author of this years ago, I would have like told him he was crazy and said, "Good luck, please try and please succeed." But I don't think it's possible. Don't feel bad if you fail. But here he is. He's what started as an experiment. He got it working, and he's built a team around it. There's I think 6 full-time devs on it now, and the open source community is growing. There's 30 more contributors on top of that have made contributions. But there's going to be bugs, there's going to be issues, there's going to be the trade-offs I mentioned. But I'm really glad that they've made it anyway. So I would definitely say that when it comes to end-to-end testing and our ability to test our user experiences, the game has changed. And I would encourage everyone to not just think about unit test coverage, but user experience coverage. End-to-end tests is where we solve that problem. And if you're new to this or trying to get started, do one thing. Write a smoke test. Test that one thing your app says it does. Test that main workflow. Do the happy path. Make sure that's good. That is going to give you 90% of the value. You're going to cover your build and your deployments and, of course, that one thing that your app is supposed to do. And from there, you can start to cover more things. But that is the one thing that you could do in maybe a day. I think I had the first few views of our app tested in like an hour or two, and then I just went from there. There were dozens of views. It was a lot of another enterprise app, but it didn't take long to get that going. And I like to say this: don't let your users test your app, because if you're not automating these things, that's what you're doing. You could have a QA team. You could be smoke testing this yourself in your own browser. But there's no way you're going to catch all the things that these automated tests can catch as quickly as they can catch. I mean, to test those things manually, what's your dev cycle? You're just creating a feedback loop that could be so much shorter. And these things can run very quickly and catch so much more. So Atwood's law. Any application that can be written in JavaScript eventually will, right? I think this is a good thing. Just a couple of weeks ago, I was working in Visual Studio Code, and I thought, wow, I remember when Atom came out, and before that I was using Sublime. Sublime was great. Like, everybody loves Sublime. Everyone at least used to love Sublime, and maybe we've forgotten about it a little bit because we've had Atom come out. And at the time, it was like, oh, this is written in JavaScript, an editor? This is fast. This works. This is crazy. And in Visual Studio Code, and I'm thinking now, when I use Visual Studio Code or Atom, I'm not just using those editors, I'm using all these extensions and plugins. There's these ecosystems of tools that have built up around these tools because they were written in JavaScript, because they're written in the things that we're familiar with. And I look at Cypress, I still think we're very much in the early days. It's still gaining adoption. People are still catching on. People are starting to write custom commands. People are starting to write plugins. Like, we're in the early stages of seeing that ecosystem expand and grow and become something beyond what the original authors intended. I really want to thank the Cypress team. They did an amazing job. They definitely ran into all these problems I described that I experienced with Selenium, and said they wanted to do better, and they have. They've built something that not only was written in JavaScript, but tried to solve the developer experience, and tried to make that smoother, and tried to make it encouraging for us to write these tests that aren't always easy. And I think they've done a terrific job. I think their docs are great, but if you need more help than what's in their docs, check out their Gitter chat. I promise you they're really nice and friendly. I want to finish my story, my personal story. This is my family and Nicholas's family. We each had a daughter 2 years ago. They were born a month apart. Our wives are both expecting our second this summer. I really wanted to bring my family here, but my wife is 5 months pregnant, and my daughter is 2 years old and wants to climb over everything. I actually asked my wife's doctor if I should, and she yelled at me. She said that would be a very bad idea. I miss them very much, but I will also say that Nicholas and I, still talk for hours, and he's still teaching me things. And I'm so grateful for having met them at JSConf 5 years ago. Thank you for joining me today, for wanting to hear about how to write tests, about how to do this better, about what's changed. I hope I've given you some ideas about that. I hope I've given you some ideas about what's happened in our ecosystem and what continues to happen with our tooling and how that continues to advance. If you want to talk to me after this, I love talking about this stuff. Please come find me or find me on Twitter at Will's Lab. I really appreciate being here. Thank you.